In this video, we will learn about potentiometer. A potentiometer is a device used to measure an unknown EMF or potential difference accurately. Potentiometer is one device which doesn't draw any current from the circuit and still measures the potential difference, so it acts as an ideal voltmeter. Construction: as shown in the diagram, a potentiometer consists of a long wire AB of uniform cross-section, usually 4 to 10 meter long, of material having high resistivity and low temperature coefficient such as constant or manganese. Usually 1 meter long separate pieces of wires are fixed on a wooden board parallel to each other, and the wires are joined in series by thick copper strips. A meter scale is fixed parallel to the wires. The ends A and B are connected to a strong battery, a plug key, an ammeter, and a rheostat. This circuit is called driving or auxiliary circuit, which sends a constant current I through AB. A jockey can slide along the length of the wire. Now, principle. The basic principle of the potentiometer is that when a constant current flows through a wire of uniform cross-sectional area and composition, the potential drop across any length of the wire is directly proportional to that length. As shown in the diagram, if we connect a voltmeter between the end A and the jockey, it reads the potential difference V across the length L of the wire AJ. Then, by Ohm's law, V is equals to IR, and by putting the value of R, that is rho L by A, for a wire of uniform cross-section and uniform composition, resistivity rho and area of cross-section A are constants. Therefore, when a steady current I flows through the wire, then I rho by A is a constant, and that constant is denoted by K. Hence, V will be equals to K into L. Or you can say that V is directly proportional to L. This is the principle of the potentiometer, and if you draw a graph between V and L, will give you a straight line passing through the origin O. The potential gradient means the potential drop per unit length of the potentiometer wire is known as potential gradient. So K is equals to V by L, means the potential gradient, and hence its unit will be volt per meter, and the practical unit of potential gradient is volt per centimeter. Now, the sensitivity of a potentiometer depends upon the potential gradient. potential gradient of a potentiometer is small, then the potentiometer is more sensitive and hence more accurate. The sensitivity, therefore, for a given potential difference can be increased by increasing the length of the potentiometer wire, and for a potentiometer wire of fixed length, the potential gradient can be decreased by reducing the current in the circuit with the help of a rheostat. Applications of potentiometer. The first application of potentiometer is comparison of EMFs of two primary cells. As shown in the adjacent diagram of this slide, the circuit diagram is for the comparison of EMFs of two cells. A constant current is maintained in the potentiometer wire AB by means of a battery of EMF E through a key K and rheostat. Let E1 and E2 be the EMFs of two primary cells which are to be compared. The positive terminals of these cells are connected at end A of the potentiometer wire, and their negative terminals are connected to a high resistance box, a galvanometer and jockey through a two-way key. A high resistance R is inserted in the circuit from the resistance box to prevent excessive current flowing through the galvanometer. As the plug is inserted, the cell of EMF E1 gets introduced in the circuit and the jockey J is moved along the wire AB till the galvanometer shows no deflection. Let the position of jockey be J1 and the length will be AJ1 equals to L1. If K is the potential gradient along the wire AB, then at null point E1 will be equals to KL1, and similarly by inserting the plug between B and C, the null point is again obtained for the cell E2, and let the balancing length be AJ2, that means L2, and therefore E2 will be equals to KL2. Hence, the ratio will be E1 by E2 equals to L1 by L2. If one of the two cells is a standard cell of known EMF, then the EMF of the other cell can be determined. And in order to get the null point on the potentiometer wire, it is necessary that EMF E of the auxiliary circuit battery must be greater than both E1 and